Hello once again, pre-calculus people. So the last couple of days we've been talking about function operations as far as started off with just the normal operations, add, subtract, multiply, divide. Then we talked about compositions. And then the next step of that is to talk about the inverses of functions. And even when we talked about compositions, we saw kind of a special case where we did the two compositions and they came out to be the same thing on both directions. And when that happens, that's an inverse. So we'll talk more about that in a couple minutes. But for the first, we just want to know how to find an inverse. And ladies and gentlemen, it is always these kind of steps right here. So the easiest way to do it, if a function is written in function notation, the easiest way to write it is y equals. If it's already at y equals, then you're good. You don't do anything else. Once you have that, you're literally going to switch the x and y values. Once you have those switched, you're going to solve that new equation for y, get y by itself. And remember, we're always going to do the opposite thing. And I got kind of a table of things, opposite operations. You're always just remember your algebra is kind of the upshot of that. And then once you get y, once you isolate the y, then we just use our notation. This -1 is not an exponent. It's just how we notate that we have an inverse of the original function. Okay. So I'm going to jump right into it. Again, this is kind of your table of opposites, as it were, your opposite operations. But again, it's just some knocking some rust off of some of the algebra there. Okay. So the first one, my first one, f of x equals 4x minus 5. I kind of did the first couple of steps for us. So again, function notation, I'm going to write it as y, not change anything. When you switch, you literally switch the x and y values. Now we're going to solve this for y. So I'm going to do this over here to the side so I can have some more room. So again, we know we need to add 5 to both sides. We got x plus 5 equals 4y. And then we got to divide by 4. I think the best way to write this is, remember, anytime you're dividing, you need to divide everything by that number, right? There's other ways you can write it too, but I think this is the most consistent way to do this. So once you have this, it would be y is equal to 1/4, x over 4 is same as 1/4 x plus 5 over 4. Now that's my y is by itself, right? So to write our final answer in the right format using my notation, I could write f inverse of x is equal to whatever this is, right? So it'd be 1/4 x plus 5/4. Okay, and that's it. That's finding an inverse. You do the same thing every time. It never changes. Okay, so read, write, switch, solve, done. So again, rewrite it. F of x, I'm just going to rewrite it as y. Y equals -3/4 x plus 2. Switch the x and y values, literally. Don't change any numbers. We're just switching the variables. Solve it, and again, I'm going to do this over here. So the first thing, we can subtract by 2. And when you want to get rid of a fraction that's a coefficient, remember, we can just multiply by the reciprocal. That's the easiest thing to do. So on both sides, multiply by -4/3. And so my final equation, and again, I can distribute that -4/3, right? So my y is going to be by itself now, so it'll be -4/3 x plus, if you multiply that across there, it's 8/3. Okay, and again, that's my answer. And I can even, I can leave it just as y to the minus y inverse, or probably best if you use function notation, if you start with function notation. So f inverse is equal to -4/3 x plus 8/3. And that'll be your inverse. Okay. Everything else is just the same, guys. So I'm just going to run, and some of the other examples have some roots and some radicals and stuff like that, but it is 100% the identical process every single one you see of these. Okay, so let's take a look at this one. So again, all we got to do is switch. So we just switch them. We have x equals 2y squared minus 7. Again, get y by itself, so I'm going to add 7 to both sides. Divide by 2, and remember what we said, we want to divide everything by 2. So it's going to be 1/2 x plus 7 over 2 is equal to y squared. Okay, I'm not done yet. So now we got to get rid of the square. So how do we get rid of a squared power or a second power? Take the square root of both sides. So it's this. And that is equal to y. And again, now that y is by itself, my final answer is y inverse equals square root 1/2 x plus 7 over 2. And I can't do any simplifying, so that I'm just going to leave the answer just like that. Okay. Switch, solve, done. And again, just keep in mind your opposite operation. If you have a square, take the square root. If you have a square root, take the square. Always doing the opposite. How about number 4? So again, we already have y, so all we got to do is switch them. So x equals the cube root of 4y plus 1. And again, what's the opposite of a cube root? If you have a cube root, opposite, just cubing. In other words, both sides to the third power. So we raise both sides to the third power. It'll be x to the third equals 4y plus 1. We can subtract 1 from both sides. Equals 4y. I'm going to come up here and divide by 4 everywhere. So I'm going to write that as 1/4 x cubed minus 1/4 equals y, and that's it. Once I got y by itself, I have my answer. So y inverse equals 1/4 x cubed minus 1/4. Okay, a couple more examples on the back, and then that's going to be it for that. Okay, and I got a bunch of them. I'm going to run through these pretty quickly. Some of these, like the rational function with a fraction, these get a little bit, they're not any harder. You still do the same thing, but you got to think about a couple different things algebra-wise. So again, first things first, I'm going to rewrite it just with y instead of f of x. Switch the x and y. Now to solve this, remember we want to get y by itself, right? So we want to move this whole thing over here because we can't have it in the bottom. We don't want y in the denominator, right? So we're going to multiply both sides by 3y minus 4. So it's still going to be multiplied by x equals 5. Well, now I can just divide both sides by x. I want to get rid of the x to the other side. Okay, so if I divide both sides by x, you get 3y minus 4 equals 5 over x. And now I can just keep on getting y by itself. So add 4 to both sides, 5 over x plus 4. And then I can divide by 3. Remember, dividing by 3 is the same thing as multiplying by 1/3. So if I multiply both sides by 1/3, I make it a little bit easier for that to be written. So it'll be y equals, again, distribute that 1/3 through. So it'll be 5 over 3x plus 4/3. And that is your inverse. And again, we have function notation, so I'm going to write it as f inverse of x equals 5 over 3x plus 4/3. One more, and this is about the most complicated one you're going to see here, like on a test even. So let's go ahead and do this one. Remember, when you're doing this, after we switch everything, we do need to get, like, again, make sure you're doing this in the order that we need to do it in for algebra. So we need to isolate the radical first, and then we can start getting the y by itself. So subtract by 5. Divide by 2, and again, we can divide by 2 everywhere. So we have 1/2 x minus 5/2 equals square root 8 minus 3y. And again, always doing the opposite. We can square both sides. So we have 1/2 x minus 5/2 quantity squared equals 8 minus 3y. And I'm not worried about multiplying this out. I'm just going to keep it like this in this case. Now we can keep on going. Subtract 8. And then divide by -3. And in this case, since I'm dividing the whole side, and I got some parentheses in here, all I'm going to do here, I'm just going to write this whole side divided by -3, and kind of call it a day. Okay, so that's going to be 1/2 x minus 5/2 squared minus 8 all over 3. And again, remember, that's going to be my y by itself. So that is going to be my y inverse. Last two. This one has an x on the top and the bottom, so this one's going to be a little bit trickier, just as far as getting y by itself. But again, first of all, I'm just going to rewrite it. Switch them. In this case, both x's are going to get a y, so it's going to be x equals, anywhere where you see an x, you're going to write a y. Same trick we did on the previous one. We need to multiply by y plus 3. So you got y plus 3 times x equals 2y plus 1. Now in this case, I do need to distribute because I'm going to have to get all of my y terms on one side. So I'm going to distribute that through and write that as xy plus 3x equals 2y plus 1. Now we got to get all the y's over. So I'm going to subtract 2y from this side, and I'm going to subtract 3x and go to that side. So it's going to be xy minus 2y equals negative 3x plus 1. Make sure you see why I wrote it that way. If you need to pause the video, go back and kind of replay that. Make sure you see the process of getting those y's together, because now I can factor a y out and then divide by that x minus 2. So you have negative 3x plus 1 divided by x minus 2. Y is by itself, and that is going to be your inverse. So we're going to write that as f inverse of x equals negative 3x plus 1 over x minus 2. And one more example. I decided to put an exponential in here for you again, just because on that front table, I did make a line for that. So anytime you see an exponential function, you're going to take a logarithm back to an exponential, opposite functions all the time. So again, we start out the same way, switch the x and y. First thing we got to do is we got to isolate where the variable is. So we're going to add 1 to both sides. And then divide by 2. So it's going to be x plus 1 over 2. It's going to be equal to e to the y plus 2 power. Now we take the log of both sides, or in this case the natural log since it's e. So we can do the ln of x plus 1 over 2 is equal to y plus 2. And now just subtract 2 from both sides. So we have the ln of x plus 1 over 2 minus 2, and that is equal to y. So my final answer is just that function. The y inverse is ln x plus 1 over 2 minus 2. Okay. Algebraic ones, most of the ones we're going to ask you to do, guys, are going to be fairly straightforward, like the first ones on the front page. The most complicated you're going to get would be like on number 6. But it's good to know like the process for all these different kinds of functions. Last little bit, now this is kind of what we did when we did compositions. To prove two functions are inverses of each other, we just take the composition and see what happens. If they both equal x, exactly x, then they're inverses. If they equal anything else, they're not. Okay, so let's do f of g of x here. F of g of x would be 2 parentheses 1/2 x minus 1/2, and then plus 1. Distribute that, see what happens. So that's 2 times 1/2 is 1. So that's 1x minus 1 plus 1, and sure enough, that does equal x. If we do the other direction, f at g of x, g of f of x, so we take this and plug it into here. So it's 1/2 parentheses 2x plus 1 minus 1/2. And again, that's equal to x plus 1/2 minus 1/2 equals x. F and g are inverses. Again, if that doesn't happen, then it's not. So let's do this one real quick. F of g of x is equal to negative 1/4 times negative 4x plus 20 minus 5. And that's equal to, that's positive x, so we're good there. And then negative 1/4 times positive 20, that's minus 5. Minus 5, that's x minus 10. So already that is not in, they are not inverses. Has to equal exactly x in order for them to be inverses. Okay. That is what you need to know about inverses. If you need some help, you can come to tutoring, send me an email, let me know what I can do to help you. Until next time, stay safe.